Hi everyone, in this video we're going to go over how to calculate vector components from a resultant vector. Here's resultant vector A, and it is pointing in some direction. So I am going to try to figure out the x component and y component value of that vector. In order to do that, we're going to have to know our trig functions. So you should be familiar maybe with the word SOHCAHTOA, which what this word tells you is what is contained in each of the three trig functions. The first letter stands for sine, cosine, and tangent, and it is always the sine of the angle, or cosine of the angle, or tangent of the angle. On the other side of the equal sign, the other letters stand for either opposite or hypotenuse and adjacent. So for sine, it equals the opposite over the hypotenuse. For the cosine, it equals the adjacent over the hypotenuse. And remember, adjacent means up against. And for the tangent, it is the opposite over the adjacent. Okay. You're going to want to remember SOHCAHTOA and the spelling of it so that you can generate the equations just from memorizing this acronym instead of memorizing three different equations. And for our purpose of solving for the x component here, we are given the angle, theta, and the hypotenuse for each of them. All right, so we know the theta and the hypotenuse for each of them. Now, we are looking for the adjacent, so we have to identify what functions have adjacent in it. The two that have it are cosine and tangent, right? But we also have the hypotenuse. Tangent does not have the hypotenuse in its equation. So to find the x component, we're going to use the cosine function. So I'm going to rearrange the equation and put in different variables from what's given in my drawing there. So I'm going to have the cosine of theta is equal to the adjacent. The adjacent side here is ax, and the hypotenuse is the value a. And our job here is to solve for ax. So I'm going to manipulate this so that ax equals, and all I have to do is move the value of a, the resultant vector, over to the other side. So you just get that ax equals a times cosine of theta. Now if we wanted to solve for the y component here, we would have to pick a different function. Now we want to find the opposite side using the angle and a hypotenuse. So now we're going to use the sine function. So the sine of theta is equal to ay over a. And we solve it the same way, so that ay is equal to a sine of theta. And as long as we draw the x and y first from our given vector and direction, so if we draw the x and we draw the y, so that's our triangle there, every time we want to solve for an x component, we will have the adjacent side to the angle, and anytime we want to solve for the y component, we would have the opposite side of the angle. So for vector b, cosine still solves for x, sine still solves for y. If we go into the third quadrant, here's our resultant vector, and we draw our x, then our y. Again, you can see that the x component here is adjacent to the angle, so you would use cosine, and the y is opposite the angle, so you would use sine. So this is really a generic solution for solving for x and y components. The one caveat is that you have to draw the x, then the y in the triangle. If you don't do that, then you end up with something a little bit different here. So you'd be given your resultant vector, but then you'd have to draw in your components. So here's my y component, here's my x component. Now what we find is that the angle that we're given is not within our triangle, so we can't use angle theta. We're going to end up with a different angle. I'm just going to call that phi. All right. So in this triangle, if I wanted to solve for the x component is opposite of phi. And I still have my hypotenuse. So now it's opposite over hypotenuse, and that's ax over a. So solving for ax, you can see that it's not the same equation that we solved for before. Before it was ax is equal to a cosine of theta. And theta is always given with respect to the x-axis, which is what we want. And that's how directions will be given to you most of the time. Once in a while, they'll give you a triangle that does look like this with the given angle that's right here. And you can go ahead and think through that on your own of how you're going to solve for whatever component it asks you to solve for. This is just kind of a standard that most people follow, or textbook kind of lay out for you. So let's just summarize here that anytime you're given a vector pointing in a direction to solve for the x component, you would pick the cosine function, but you're basically going to take the magnitude of the hypotenuse and the direction of the hypotenuse and plug it into that equation using the cosine function and get ax. If you use the sine function, you will get ay. And again, this is the hypotenuse, this is the direction that that vector is pointing. And that's how you solve for most x and y components.